Hi guys, welcome. We're looking at Math 7, Day 22. Today we're doing lesson 68 and 69. So algebraic addition. So addition, we know is can add integers, we're going to add rational numbers, decimals, fractions, all of those things. We can also add and subtract negative numbers. So again, remember every whole number has an opposite. So 1, -1, 2, -2. It's the same distance from the origin. So we call them the opposite. So 3 and -3 and -3 and 3. 4 and -4, those are opposites because they're the same distance from the origin. Understanding those opposites can kind of help us because if we have 7 minus 3, we know that equals 4. We don't need to draw out a number line or even use a calculator. We can come up with that pretty simply. But then algebraic addition, we can also write this as 7 plus -3, which equals 4. If we have 7 minus a -3, that would be 7 plus 3. If we have 7 plus negative of a -3, that's the same as 7 plus 3. Again, I think they overdo it with the signs. They sometimes use positive sign for a positive integer when we know if there is no sign, it's positive. So again, I think sometimes they overdo it with the brackets and the braces and parentheses and the signs, but we'll show you what we're talking about. So if we have -3 minus -2, representing, okay, -3 minus -2. Again, you can have the parentheses here if you want. I usually rewrite it without, just out of habit. But if I have -3 minus -2, well, I know a negative and a negative make a positive. So if I'm subtracting a negative number, I always like to get it simplified so there's one sign between whatever we're doing addition or subtraction. So the negative and negative actually make that positive. So now I have -3 plus 2. -3 plus 2 just equals -1. So before you just jump in, or I'll show you guys calculator you got to be a little careful with because our subtraction and our negative sign, I know they're the same when we write them, but as our calculator goes, we can't use the two negative signs on there interchangeably. We have to use the one on the right between addition and multiplication for subtraction, and then the one by our decimal in the parentheses, that negative sign when we're making a number negative. So if you get an error message or something doesn't look right, it's probably just mixing that up. But again, we want to be able to do this without jumping straight to a calculator anyways. So if we have example 2, okay, all of these negative signs, let me rewrite it. I have a negative of a -2 minus 5 minus, again, I don't like when they do this. So again, if you put in a positive number with a plus sign in your calculator, you'll often get an error message for that too. So just kind of be aware of that if you're putting this in. So a negative of a negative, well, negative, I got to change the sign of this, negative and negative, make this positive, and you can put +2 if you want. I prefer just to call it 2 because I know it's positive. -5, so there's only one sign there, so we're good. Minus +6, well, that's just -6. So again, 2 minus 5 gives me -3. -3 minus another 6 gives me -9. Again, you can draw your number line and start at 2 and then move 5 to the left and 6 more to the left if that helps you. I think the further we go along, we'll get away from drawing out those number lines and you guys will just kind of become automatic with this, just like addition and subtraction of positive numbers. But for right now, if it helps you, you can do that extra step. It's just a little bit more time consuming. If we look at example 3, we have -1.2 minus positive minus 1.5. So if I was writing this on my paper, I would just do -1.2. I wouldn't include the parentheses. You can if you want, and then I would just call it minus 1.5. Okay, so I know negative 1.2 minus 1.5. Again, if we want to think of this in terms of addition, the way they've been showing us, okay, we can think of this as plus a negative 1.5 and then kind of think about opposites. Well, 1.2 plus 1.5, if it was positive, 1.2 plus 1.5 would give me 2.7. So if it's the opposites of both of these and I'm adding them together, then it's going to be negative 2.7. So that's another way to kind of think about it, is using those opposites and what you know about adding decimal numbers and applying that to their opposites. So 1.2, negative 1.2 plus negative 1.5 gives me negative 2.7. And again, we can do this on the calculator. You guys should know how to put decimals and everything in there. I just think, again, they overdo it with the signs. This looks really kind of muddy to me and makes it a lot more complicated than I think it really is. But if it kind of helps you to see it, or drawing the number line helps you, use whatever helps you initially, and we'll, through repetition and practice, you guys will get this down. Okay. Next, we're looking at lesson 69, scientific notation, the proper form of scientific notation. So remember, with scientific notation, we have a coefficient that's always got to be greater than 1. One or greater, and it's got to be less than 10. So we have to have a value in the ones place, and then everything else to the right of the decimal. So if I have 4,600 times 10 to the power of 5, and I want it to be in scientific notation, well, I'm going to make this 4.6, and that's moving the decimal 1, 2, 3 times. So that's why I do 10 to the power of 3, because I move the decimal 3 times. And then I can apply my rules of exponents, same base. So I add the exponents. 3 plus 5 is 8. And so 4.6 times 10 to the power of 8. So if I have 25 times 10 to the power of negative 5, again, this is greater than 10. I have my decimal would be right here, not right here. So that's where this is not proper scientific notation. If you get a test question, this is your answer, you're going to lose half a point because this is incorrect. So what we do is we want to move the decimal here to 2.5. Now, I'm not done. I can't just move a decimal arbitrarily and say I'm done. When I do that, that's essentially 25 to 2.5. I'm dividing by 10, which means I need to multiply this by 10. So I always think, okay, I moved it left, divided by 10, I need to multiply this by 10. So if I multiply that by 10, or 10 to the power of 1, I would add those exponents. I'd add 1 to my exponent. So I'd get 2.5 times 10 to the power of now negative 4. The next example is just the opposite. We have a number less than 1, so the decimal needs to be right here. So 0.25 times 10 to the power of 4, so I need to multiply this by 10 to make it 2.5. Can't just do that and be done. If I multiply by 10, I need to divide by 10. Okay. Or 10 to the power of 1. I subtract the exponents. I just really am taking 1 away from the exponent. So if I move the decimal to the right, I'm multiplying by 10. I need to take 1 away. The example we just did, we moved it left, which made it bigger. So we needed to add 1. Or sorry, yeah, we moved it left and made it smaller. So we needed to add 1 to the exponent. So we need to end up in a form where our coefficient is with the decimal place 1 to the right of our ones place, and then everything else to the right. So this is correct form. This, what we started with, would not be. And again, we can think of 0.25, we could write that in its own scientific notation if that helps you to write it out. 2.5 times 10 to the power of negative 1. Again, 4, negative 1 plus 4, 4 minus 1 is 3. So we took 1 away from that exponent, kept it equivalent, but it's now in proper scientific notation. Okay, we'll go over that practice set together, and then we got one more lesson in this unit, and we'll be reviewing for a test.